Today we're going to talk about Datalake 3.0. I'm Sumitra. I run Hadoop Core Product Management Hortonworks, and I have with me my fellow good colleague Brandon. He's going to walk you through our demo of Datalake 3.0 manifestation. So really, if you look at Datalake 3.0, what it is, we'll start with history first. So Datalake 1.0 is all about enabling batch workloads on a single platform, a single data lake. When Datalake 2.0 happened, we focused on bringing real-time workload like HBase, Hive, along with the batch workloads. Now, in 3.0, the focus is on application now. Instead of focusing on a platform, we want to bring applications in a manner it's conducive to time of deployment, time of insight, and it's all about application like IoT applications, cybersecurity. Now, if you look at Datalake 3.0, there are three main building blocks. And today we're going to kind of cover most of the three building blocks today. So as you can see here, it's Hadoop storage. That's where all the data sits. It's billions of files. We want to make sure when you store data for long term, 5 years, 10 years, we don't have three replicas. We store in a very efficient manner and reduce less than 2x number of nodes. And also want to make sure in the cloud world, we can tier to the public cloud. So that's Hadoop storage. Yarn is a compute and memory platform. So the focus here is all about enabling Dockerized applications, so we reduce time to insight, time to deployment. And once we have the building blocks, we now we can stitch together different groups of applications. It can be IoT application that has Kafka, Spark. It can be cybersecurity like Metron, all coming together as a group of apps. The focus here is you download the app, customize the 10% for your own company, and deploy in this Hadoop Datalake 3.0. And of course, third building block is all DR backup. Once you have the business critical apps running on your Hadoop Datalake 3.0, we're going to make sure it's business critical, it's enterprise ready. So we're going to provide you DR to a different site. It can be on-prem site, it can be a cloud. We're going to make sure we enable you backup restore, and these are all policy driven. You don't have to manually manage them. So that really puts it down as a Datalake 3.0 story. So a little more detail on Datalake 3.0. So you have seen as I was talking about Datalake 2.0. It's all about today. We focus on creating different clusters. For HBase, you have a different cluster. For Hive, you have a different cluster. Spark, different clusters. It takes days to create clusters. And these are all siloed, low utilization. What we envision is creating a single data lake. You can store billions of files in the data lake. And once you have the data lake, you can deploy different kinds of applications. It can be your entire HDP stack. Baseline, you have HDP running. You have HDP 2.5 running, 2.4 running. Or you can have a group of Spark bursts running side by side. Or you can have groups of assemblies running. If you look at this picture here, this is our Datalake 3.0 story. So in Datalake 3.0, this is our baseline cluster. Think about this is our next generation major version coming out. So we have our own HDFS, Yarn, Zookeeper running, and Docker running. And once you have a baseline running, then all you're going to support Dockerized apps on top. Now you can run your own HDP 2.5 on top. It can be tested, it can be production, but the idea is that you don't have to create a new cluster for that. You can run your different Spark versions, or you can run assemblies of apps. So you don't have to focus on the cluster, you can focus on the applications. Okay? Now, this is the manifestation of Datalake 3.0. So as you can see here, it's all single set of machines we are sharing and creating a big Datalake 3.0. So we have a cold tier. That means we are going to use user coding, Rich Solomon, and that's going to reduce your storage overhead by 2x compared to what you have today. So you can store data for 10 years, 5 years of historical data. You don't have to worry about a TCO reduction. Now, on a hot side, you also have hot data coming to SSDs. So for that, you can use 3 replica approach and keep a hot copy. And also on top of that, on Yarn, we're going to enable pulling all the GPU resources or FPGA resources in a cluster-wide resources. You don't have to pull GPU on in per node now. It's across the cluster. And once you have it, you can have multiple tenants coming in and using that GPU resource and run deep learning TensorFlow framework on top. And the way we're going to enable is, if you look at this entire data lake here, we build this with Datalake 3.0. Now we have our own cloud orchestration. That can help you create the logical cluster you want. It can be HTTP 2.5, 2.4, or it can be running your own assembly of apps or Spark side by side. Here, our next generation engine will make sure we can do tiering between hot and cold data lake, or we can do DR to other sites, to the on-prem side or a cluster. And last but not least, Ambari is being used to manage each cluster within the data lake. So today, we're going to kind of talk about the vision today, and our goal is to give you a flavor of what's coming. So it's going to be a couple of phase approach. So our first leg of the journey is going to be, we're going to deliver in 2017. And we have Brandon going to demo you what's coming this year. Thank you.
Hi, I'm Brandon Wilson. I'm a solution engineer with Hortonworks. Today I would like to provide a quick demonstration of our cloud orchestrator deploying Dockerized HDB clusters to a bare metal Datalake 3.0 cluster powered by Yarn. When we first log into the orchestrator UI, we are presented with a global view of all clusters that I have already deployed. In this case, there is just one called Demo Cluster. In the next few minutes, I'll walk through the process of deploying a second cluster. First, let's take a tour, though, of the configuration sections within the UI. The API instance is a RESTful endpoint for Yarn. This endpoint is what the orchestrator will use to create the Yarn containers and launch the Dockerized apps that make up our cluster. I will create a new instance of this endpoint that is hosted in my Datalake 3.0. To do that, I simply select the yCloud endpoint. I will give it a name. In this case, Demo Cluster 2, and the endpoint. Now that I've created that endpoint, the next section is the resource profiles. These profiles are used by the orchestrator to specify the resources that will be allocated to the Yarn containers that will host our Dockerized cluster components. For example, the large profile is allocated 4 CPUs and 16 gigabytes of memory. We can create additional custom resource profiles if we wish. Finally, we have the blueprint section. Blueprints are a feature of Apache Ambari that allow a user to define the custom configurations and component layout of a cluster via JSON so that a cluster can be deployed automatically via a RESTful endpoint as opposed to walking through the manual deployment interface that Apache Ambari exposes. In this case, we have just a single blueprint which represents an ETL EDW type cluster. We can imagine many other blueprints that we could include here, such as a data science blueprint for Spark and machine learning workloads, or a combined data science and EDW blueprint that would provide both Spark and Hive services. In this case, if we look at the blueprint, we can see the details down here in the JSON, and we can see the actual configurations that are allocated in terms of heap size for specific components, and we can also see in terms of which hosts are running which components in the cluster. So in this case, a master runs these particular services. We can build these manually, but we can also export them from an existing running cluster if we have one. Now, to deploy a cluster, we simply scroll back to the top and we select our API instance, Demo Cluster 2. Now, when we click on Create Cluster, we can assign a cluster name, and we can choose a blueprint and kick off the installation. The orchestrator will deploy a single Yarn container for each master and worker using the associated resource profiles. So in this case, we'll choose the blueprint, and we'll choose the large resource profile for the masters and workers. And I'm doing this as a demo, so I will simply deploy one of each type. Finally, we can review and launch and create the cluster. The installation will take approximately 15 to 20 minutes, and you'll be presented with a cluster complete notification in the UI when it is done. If we click on my previously prepared cluster, then you can see that the management of the cluster is surfaced via Apache Ambari as a standard with any HTTP deployment and is linked via the orchestrator interface. We can log in and see the familiar management console. And this was the mirror image of what I just started the deployment for. So you can see that when this launches, we have essentially a data warehousing type workload or a data warehousing type cluster here where we have core HDFS, Yarn, and Hive is exposed as well. And here we also have Spark. And once again, there's one data node alive and one master. Now going back to the orchestrator, when we are done with this cluster, we can simply click terminate, and Yarn will automatically take care of cleaning up the resources and the containers under the covers for us and release them back to the Data Lake cluster for others to use. Using this orchestration tooling, we can quickly deploy HTTP clusters for dev, test, and other ephemeral purposes, and all the resource management is neatly controlled via our existing Yarn installation in our Data Lake. The underlying capability to deploy Docker containers within Yarn is an even more generally useful tool. We can leverage it to run any application that can be hosted in a Docker container within a Yarn cluster. So, in a future video, to demonstrate this power, we will show you how we can use this feature to deploy and run a TensorFlow cluster all on top of Yarn in Dockerized containers. This custom assembly will be used to train and apply machine learning models. Until then, take care and thanks for taking the time to check out our demo.
So you have seen Brendan's exciting demo, so that shows you what you're doing this year. And it's a lot of exciting stuff coming. And if you learn more, please reach out to at this contact ID. So you can either reach out through the email or you can reach us through your sales rep. We'll be happy to work with you in 2017 and make this a reality. Thank you very much.